Hello, we are going to continue talking about ECG part 2. As we said before in the previous video, ECG is an electrical signal that that are produced by the pacemaker of the heart through generation of action potential, and that action potential will stimulate contraction. But before we start dividing the action potential, we should remember that signals that are generated by the SA node will go from the right atrium to the left atrium and then travels to the AV node to go to both ventricles, and that's how the whole heart is being stimulated. Okay, the action potential is divided into monophasic and biphasic. Monophasic is considered as an electrical current that travels only in one direction, but biphasic it's the current that travels in two phases, or at this phase we use two surface electrodes of opposite polarity, and that's why we call it biphasic. There's two poles. Biphasic is divided also into unipolar and bipolar. The bipolar, we use the two poles are exploring. That means that the two poles have a polarity. Before we start, we shouldn't be familiar with a concept called vector. Vector is an arrow that represents the sum of electrical activity, and the electrical activity always directed from the like to the left and downward, always to the left and downward. So any electrical activity that goes to the left side is going to take the positive pole, and if there's downward, the downward going to take the positive pole, as we are going to see here in the bipolar. Okay, bipolar consists of three leads, lead number 1 and 2 and 3. In this picture, we can see a triangle, kind of equilateral triangle. And what is this triangle? This triangle represents something we call Einthoven triangle. What is Einthoven's triangle? It is an imaginary formation of three lymph leads in a triangle that are used in ECG. We use the right hand and the right arm, the left arm, and the left leg, not the right one, the left leg. Usually the right leg used as an earth. We do not use it to calculate or to measure the potential. The shape forms an innervated equilateral triangle, as we said before, and the heart's gonna be at the center. What is special about this triangle is that it is equilateral, as we say. Equilateral means that the sum of the electrical activity is going to be zero at the middle. Okay, let's start with the leads. Lead number 1, as we can see at the picture, it records the difference of potential between the right arm and the left arm. As we said, because the right arm, the left arm, because the potential is going to the left arm, so the left arm going to take the positive ball and the right arm going to take the negative. And the same thing for lead number 2 and 3. Lead number 2, it records the difference of potential between the right arm and left leg, so it goes downward. The left leg going to take the positive ball. Lead 3, it records the difference potential between the left arm and left leg. Again, it goes downward, and the left leg going to take the positive ball. We said that the sum of these electrical electrodes going to be 0. Now, let's go to the unipolar. The unipolar, what is the difference between the unipolar and bipolar? That is, the unipolar, that the bipolar consists of two exploring electrodes. That means that the two electrodes have a pole, one positive and one negative. but it's not the same thing for unipolar. Unipolar, we use only two electrodes, yeah, but one is an exploring electrode and another one is what we call indifferent electrodes. That means it's zero. Like for further explanation, that the unipolar, we use one limb electrode as a positive pole and take the average of inputs from the two others as a zero reference. What does that mean? You're going to understand when we explain it furthermore. The unipolar is divided 3 at the lamp and 6 at the chest. 3 at the lamp, there are the AVR, AVL, and AVF. AVR, we calculate the potential at the right arm, the AVL at the left arm, and the AVF at the left leg, or we can say left foot. So how we calculate or how we measure the current or the potential at the right arm, let's come back here at this picture. The right arm gonna be the exploring electrode, and the both left arm and left leg going to be the reference or the zero potential. How is that possible? We know that we have three electrodes, and the summation of these electrodes must be zero. So there are going to be two positive and one negative poles. And the summation of these is gonna be zero. So the potential at the right arm gonna be equal to the summation of the potential at the left arm and left leg, and that's gonna be easier for us to calculate the potential. And the same thing for the left arm and the left leg. For further explanation, we can see the triangle of Einthoven's. The right arm, the left arm, then the left leg. The summation of these three potentials gonna give us the indifferent electrode, and we connected with the exploring electrode that might be at the chest or at the limb, and so the indifferent electrode gonna be like a neutral potential. So that's gonna be really easy for us to measure the exploring electrode. Let's go now to the chest electrodes, which are from V1 to V6. Okay, first of all, we need to know where are they located. V1, we should know, like before we start, that V1 is the only electrode that is located at the right side of the sternum, the breastbone at the middle over here. But the others from V2 to V6, they're all located at the left side. V1 is located at the right side of the sternum, as we said, at the level of the fourth rib. V2 at the same level of the V1, but it's located on the left side. V3, it is between the V2 and V4. V4 at the fifth intercostal space. So V3, it's like between the fourth rib and the fifth intercostal space. V5, it is also at the fifth intercostal space, but it's like further inside, further to the lateral. We call it like anterior to the axillary line. V6, it is also at the fifth intercostal space, but it is mid-axillary line, so it is like also further lateral, as we can see here. They're all like V4, V5, and V6. They're all located at the fifth intercostal space, but like they go beside each other. Now, what is important is that how we can see V1, V2, V3 to V6 at the ECG. V1 and V2, we see them as a negative QRS. The R is like down, so we call it negative QRS. What is the QRS? We mentioned it in the previous video. You can go and check it. But what's important here that we should know that the V1 and V2 has a negative QRS, it is down. V3 and V4, like it is almost equal, as you can see here, like more at V4. Um, V5 and V6, it's a positive, which they are gonna be up there. And that's all about the ECG. Hope that was helpful and see you again soon.